Hey guys, so welcome back to the wonderful world of math. Today we're going to look at linear inequalities, so make sure that you have your date and your title. We're also going to be using this yellow glue-in that I gave you in class, so make sure you have that out. You're going to cut that around the outside and you're going to make it into a 2x2, so something that looks like this. Okay, so if you need to pause the video to get that done, please do so. But this is what you're after. And so what I'm going to do is I've kind of drawn on the screen very poorly, but I've drawn the front of this. And so we're going to fill out the front, and then we're going to go to the next page and we're going to fill out the inside of it. Okay. But on the front, we're just going to look at the 4 different types of linear inequalities that we're going to see. The first one is when we have y is greater than mx plus b. So anything bigger, right, than mx plus b, or if it's written the other way with the mx plus b on the left side, you just have to make sure that that alligator is eating the y no matter what. So these two things are the same, okay? So that's one example we're going to look at. Another one we're going to look at is y is less than mx plus b, so all numbers smaller than the line. And again, if I write it on the left, you just have to make sure the alligator here is eating the right side. So here, the alligator is eating the mx plus b. In the bottom left here, we're going to look at what if my inequality is in the form of y is greater than or equal to mx plus b. And same thing, if the mx plus b is on the left, you just need to make sure that that alligator is eating the y, okay? And then the last one, what if I have an equation, or excuse me, an inequality in the form of y is less than or equal to mx plus b?
Thanks for bringing them in.
And again, if your mx plus b is on the left, you just have to make sure that the alligator is eating the mx plus b there. Okay, so we're going to switch and we're going to look at the inside now. So the outside hopefully looks something like this. And then we're going to go ahead and fill out the inside. All right. So on the inside, just as a reminder, this top left corner was y is greater than mx plus b. You don't have to write that part, okay? That's just a reminder of what we wrote on the outside. Okay, so if I have an inequality in this form, first of all, it's going to be a dashed line. Okay, and we're going to talk about y here in a second. And then you're also going to shade above the line. And we'll talk about that too. Okay, so when I look here, I want all my y values to be greater than the line. Cannot be equal to the line, only greater than. So if I have a line, let's say it's doing this, right? It's dashed just to show that I cannot have points on the line. Cannot have any points that are equal to this line. So that's why it's dashed, just to show that we're not allowed to have points on the line. And then I want all that y values bigger than the line. Well, all my y values that are bigger than the line are above the line. So in this case, I would shade above the line. If I'm doing the next one, which was y is less than mx plus b, right? Again, I cannot be equal to this. So again, it's going to be a dashed line. Okay, so I'm just going to draw a random line. So again, it's going to be dashed. And now I want all y values that are less than the line. So now we're going to shade below the line. So shade below the line. What the shading does, there you go. So what the shading does is it tells me that any point down here, so right, see all these points I'm drawing? any of these points will make this inequality true. It'll make it work, right? I could have 4 is less than 10. I can have -5 is less than 0. Right? There's infinitely many inequalities that will work. And so any single point in this shading all over works for that inequality, whatever that inequality is. Okay. On the bottom right, again, you don't have to write this, but this is what the front looked like. Wow. Now I can equal the line. I'm allowed to equal the line. So let's say, oh, my line's doing something like that. Now it's going to be a solid line because I'm allowed to equal the line. I can have points on the line, and that's okay. All right? And then I want all y values that are bigger than the line. So again, we're going to shade above. So shade above the line. So we're looking here. Okay. And then the last one was y is less than or equal to mx plus b. So again, right, it's going to be a solid line because I'm allowed to equal. I just remember if it has a solid line underneath, right, if it has the equal to, then it's a solid line. So again, this graph is going to be a solid line. And because I want all y values less than the line, we're going to shade below the line. Shade below the line. So our shading is coming down here. So again, any point in this shaded area works. So there's infinitely many points that work. So that's what the inside should look like. Outside looks like that, right? The inside, something like this. There we go, more or less. You can go ahead and glue this in if you have the means to be able to do that. Go ahead and glue it in. And then we're going to do 3 examples on how this looks like graphing, and then we'll be done. So let's go back to our notes. And we finished our foldable. Let's scroll down and let's look at our first example, which is we want to graph x is greater than 4. So I'm going to draw my graph. I'm just trying to make your graph as pretty as possible, right? All right. So this is an inequality. But first we need to look at what does the line even look like, right? Where do I draw it? So hopefully we recognize that since there's no y, if this was an equation with an equal sign, it would just be a vertical line at 4, right? If there was an equal sign, it'd be a vertical line at 4. So it's still going to be a vertical line at 4. The only difference is now it's going to be a dashed line because x is greater than 4. So I just have a dashed line at 4, excuse me. Okay. And then how do I know which side to shade? So I'm going to show you a trick that works all the time, which is nice. So what we're going to do is we're going to pick any point on the graph as long as that point is not on this line. Okay, so any point not on the line. Well, the easiest point on the coordinate grid is 0, 0. I would always use 0, 0 as long as it's not on the line itself, okay? So I'm going to pick point 0, 0. If 0, 0 is on the line, is on the graph, pick another easy point, 1, 0, 1, 1, right? Whatever. But just try to pick something that's a little bit easy. So this is x and y, and I'm going to plug in my values. X, in this case, is 0, and I get 0 is greater than 4. Then I have to ask myself, is that true? Right? Is 0 greater than 4? And hopefully you said no, right? Not true. It's not true. So what that tells us is the point 0, 0 doesn't work. Point 0, 0 does not work. It's not an answer. So the point 0, 0, which is right here, is not included in the shaded area because the shaded area is only answers that work. So 0, 0 is not included in this shaded area. So since it doesn't work, so we're going to shade to the right. Shade to the right. So 0, 0 doesn't work. So the whole left side doesn't work. That tells me that just the right side works. And there's my shaded area. And there's my graph. Okay. So by just plugging in a number, it kind of helps you figure out what side of the line you should be shading. Let's look at another example here. So our second example says graph the solution set. So that's just the shaded area, okay, of 2x minus 3y is greater than or equal to 6. Okay, so I just want to graph this equation. Well, the first thing I need to do is set up a coordinate grid. So here's my coordinate grid. Now, I don't know how to graph this, right? This is not in slope-intercept form. I don't know what my y-intercept is. I don't know what my slope is. Great, right? So we're going to have to find what all of that is. So here's my inequality. I'm just rewriting it. And I need to get this into slope-intercept form. So I need to get the y by itself. So I'm going to subtract my 2x. And I get negative 3y is greater than or equal to negative 2x plus 6. Okay, then I'm going to divide by negative 3. And I'm hoping that we remember what happens when I divide by a negative. Right, so I get y. When you divide by a negative number, your sign flips directions. Okay, and then negative 2 over negative 3 is just positive 2 over 3x. And then 6 over negative 3 is negative 2. So let's make a note of that because it's so important, right? So switch, ooh, that's a bright green. The sign when sign multiplying or dividing by a negative number. So when you're multiplying or dividing by a negative number, you're going to flip the sign. So that's why I went from greater than or equal to less than or equal to. So now I'm at the point where I can graph this line, right? I know I'm starting at negative 2, so right there, and I'm going up 2 over 3, right? And up 2 over 1, 2, 3, over here somewhere, right? Or down 2 to the left 3, right? Lots of options. Anyway, oops, sorry, 3. There we go. Then I have to ask myself, is the line dashed or is it solid? And because I have an or equal to, it's going to be a solid line. So there's my line. Okay, and then now let's figure out what side to shade on. So I'm going to, again, 0, 0. Do you see how 0, 0 is not on the line? So I'm going to use 0, 0. 0, 0. And that's my x and my y. And I'm going to plug it in. And it doesn't matter what, I'm going to plug it into the original one. Okay, so 2 times 0 minus 3 times 0 is greater than or equal to 6. So I get 0 minus 0, which is 0. So 0 is greater than or equal to 6. And then the question is that true? Is 0 greater than or equal to 6? No, right? So not true. So the point 0, 0 doesn't work. Point 0, 0 does not work. So right here, no good. That's above the line. So above the line in general is no good. So my shading is going to go on the other side. And there's my graph. Okay, so again, any point down here in the shaded area works, makes that inequality true. Okay, we have one more let's look at. Oops, this one. So the last example is we want to graph x plus 3y is less than 6. So again, I'm going to need a coordinate grid here. So here's my coordinate grid. And my equation is not in slope-intercept form. So again, I'm going to have to find slope-intercept form. So there's my equation. I'm going to subtract my x, which gives me 3y is less than negative x plus 6. Okay, and then I'm going to divide everything by 3. And I'm not dividing by negative, so my sign does not have to change. It can stay the same. Y is less than negative 1/3 x plus 2. So now I know my y-intercept is at 2, and my slope is down 1 over 3, or up 1 to the left 3. And the question is it dashed or is it solid? Right? And it's dashed because I can be less than the line, but I can't be equal to the line. So I draw my dashed line like so. And then I'm going to pick a point to plug in. In this case, again, 0, 0 is not on the line, and that's the easiest point to use. So I'm going to go ahead and use 0, 0 again. And you can plug it in up here. So I have 0 plus 3 times 0 minus 6. So I get 0 is less than 6. And the question is that true? Is 0 less than 6? Yes, right? This is a true statement. So 0, 0 works. 0, 0 works, which means, so since 0, 0 works, that means that 0, 0 is in the shaded area, right? So here's 0, 0, that works. So that is the shaded area that we want. So we're going to shade below. Okay. So that is our last example. Hopefully that makes sense. You guys have some practice to do on Classroom. If you have any questions or if you need any help on this, make sure you reach out. And this is actually our last lesson on Unit 2. So we won't have any other videos until we start Unit 3, which is all about quadratic functions. So reach out if you need help. Otherwise, good luck, and I'll see you later.